Okay, welcome back. So last time we left off with mixtures, a physical blend of two or more substances. And let me quickly finish off what mixtures are. A mixture can be split into two different types. A homogeneous, let me spell that better. Homogeneous, homogeneous, and the other one is heterogeneous. And I believe we did go over a little bit of what each meant, but homogeneous is when there is one phase or layer to a solution. And heterogeneous, or a mixture, sorry. A heterogeneous is when there is more than one phase or layer. So like last time, I explained that air is actually a solution, a homogeneous mixture. So you only see one phase of air, whereas some like chunky peanut butter, you might call it a heterogeneous mixture because there's a one layer of peanut butter and there might be chunks of different sorts of peanuts or whatever peanut butter you're into. So let's move on to what distillation is. So distillation is a process where you take an impure substance, like a mixture of impure water, for example. So let's say we have this little beaker here with impure H2O, okay? Impure H2O. And we're trying to make this into a clean solution. So that's what distillation is used for. So there's this little pipe that runs across like this. And it's going to be we're going to apply heat to this little mixture here. Let's say that since this is water, let's say it was 100 degrees Celsius, it'll evaporate, and these particles move through this little pipe and all the way over here, and while over here through this transportation process, there's going to be this cool blanket that is covering, let's say this is like a cool blanket that's covering the pipe here. And what's happening is we're putting in cold H2O into this blanket. That way, in this section right here, the evaporated water will actually condense back. We learn the phases of matter. It'll condense back and it'll become liquid again. And it'll be pure H2O in this little vial here. It'll be pure H2O. And that's how this is impure salt, impure H2O, where after we applied heat and this distillation process has gone through, there will be little salts or whatever made this solution impure left over in this little beaker over here. That way we can separate between clean water and whatever was making it impure. Now let's move on to a concept a little bit different. Uh, we're going to move into the law of conservation of mass. And you may have learned this in your other science classes. It's the law where mass is neither created nor destroyed. You cannot create or destroy mass. So let's take an example such as A plus B is going to become C plus D. A plus B is the reactants, and C plus D is the product, are the products. Overall, A plus B, whatever the mass of A plus B is going to equal what C plus the mass of C plus D is going to equal. No matter what, the value will be the same. If it's not, then you did something wrong with either balancing the chemical equation, which we'll learn later, or there is something wrong. There must be an equality between the reactants and the products in terms of mass. All right. Now let's move into the properties of matter. So let's say the physical property. What is the physical property? Its physical property is measured or observed without changing the identity. Measured or observed without without changing the identity of the substance. And I apologize for my messy handwriting. So let's take like H2O, for example. We've been working with H2O. We're most familiar with it. It's a liquid. It is colorless. Let's see. It's a boiling point of 100 degrees Celsius, things like that, etc. It's a measured or again observed without changing the actual identity of the substance. You might think, uh, yeah, let's move on. Let's move on to the. I was going to give an example, but I'm running out of time a little. Chemical property. A chemical property is ability of a substance to undergo a specific chemical change. So let's write that. Ability of a substance to undergo go specific chemical change. So then um, let's take the decomposition reaction, for example. We will learn in more in depth of all the different types of reactions, chemical reactions. But here's what decomposition is, just to serve as an example of what a chemical property is. Let's take, again, H2O, and that's going to become H2 plus O2. No worries for how this becomes H2 plus O2 for right now. And we're no worries of how you balance it, but that's how you balance it. It's pretty intuitive. Anyways, that's an example of a chemical property. The fact that water can decompose into hydrogen and oxygen gas. It is that ability to undergo this specific chemical change. All right. Now let's go more into like what change is. So for example, let's take physical change. A physical change is when no new substances are formed. So let's take phase changes, for example. This was actually the example I was going to give earlier. H2O water is in its natural state. Well, the way we see it, well, it depends on where you see it, but the one we drink is liquid. But this can become H2O, but it's still H2O, but it's in the gas form. It's water vapor. It's still water. It's no new substance. It's still water in essence. It's a physical change. So if you're changing if you're undergoing phase changes, it's still considered a physical change. Other types of physical change are cutting. You're cutting something like a chocolate bar, or you're grinding something. Not the type of grinding where you're grinding video games, the type of grinding where like metal, you're grinding metal into like little parts of dust, or you're breaking, things like that. You get the point. No new substances are formed. Chemical changes, however, um, chemical changes is when it's the opposite. New substances are formed. Quite obvious. So let's say you take an example such as I already balanced it here. Sodium plus chlorine, and I'll explain why later, why chlorine has two. Um, it's a diatomic uh it's naturally diatomic, but I'll explain more about it in future videos. This is the chemical reaction between sodium and chlorine gas, and it makes sodium chloride, right? Um, and yes, it's already balanced. And that is an example of how you take one substance of sodium and another substance of chlorine, and a new substance, sodium chloride, which is a table salt we see today, is formed. That's an example of a chemical change. We take two things together and it undergoes a chemical reaction to form a new substance. So whenever on a test you see you're supposed to um, identify if it's a chemical or physical change, you have to identify if a new substance is formed. And make sure to keep in mind that phase changes are still physical changes. And here's some indications to help you on the test or whatever, that it is indeed a chemical change. So indication of chemical change. One example, let's just number it. Number one is heat energy is released. So heat or energy is released. Number two, solid or gas. Solid or and sometimes both. A gas is formed. Number three, there is a color change. There's a color change. So these are all things you can, if you do an experiment, you can see, you can feel of like heat energy being released. You might see a color change. These are things that may indicate a chemical change. Number four is relative irreversibility. So that means that once it has become a certain substance, and you might not be able to reverse back into its whatever it was before it became that substance. And that actually wraps up our our chapter two, matter and change. So next time we'll go into our next chapter and hope to see you there. Thank you.